All right. Hello, everyone, and welcome to the JE Champions Conference. My name is Francois. I am usually the one that is speaking at conferences, but today I have the pleasure of being your moderator. It is my honor to introduce our speaker for this session, who is Kai Horstmann, and he is presenting his talk, Effective Pattern Matching in Java. Kai is based in Germany, and he is not only a Java champion, but also Oracle recognized him with the Java Lifetime Achievement, which only a handful of people have received so far. Many of you will also know him as the author of Core Java, and if you are a bit impatient like me, maybe Core Java for the impatient. So please feel free to ask questions at any time, both in the chat and in person. Wait, in person? Yes, you heard that right. Kai is currently in Dublin, giving this talk live to the Dublin Java user group as well. Please give a big round of applause for the Dublin Jug for hosting him and for Kai.
All right, I'm messing up the mic here in the process. So, so I was awarded this wonderful poster here by the resident artist who sums up my lifetime achievement in A4, no, what is it, A3 size. So thanks very much to the users group for this invitation. This has been great. So it's very nice to have a live audience and not just speak into the dreaded camera for an hour. So thanks everyone for braving the horrible weather. I would have never come myself. All right. So here we are for Effective Pattern Matching, the 2026 edition. You'll soon know why 2026. So we'll start out by just talking about data-oriented programming. We all know object-oriented programming. It's so 1980s. And so then there was functional programming. And now the latest buzzword is data-oriented programming, where we're saying we're just going to model the data that's out there in our business domain. So I have an example here. We're doing some kind of bank transactions. We have deposits and we have withdrawals, and we have, of course, it being a bank, we have fees. And so what's a deposit? It just has an amount, and a withdrawal has an amount, and a fee has an amount, and it being a fee, it has a reason. And we're just modeling that with records, plain old records, simple. And okay, maybe we do want to have a little bit of because this is, after all, a hierarchy. There's different kinds of transactions, so we should recognize that they are all that they all have the same interface. So I have some interface, and it's a sealed interface. So I'm saying this is the totality of all of the kinds of transactions that there can be. And when I do that, I can now use this marvelous new feature of pattern matching. I can say, okay, I have an object here, lowercase bank transaction, and I'm going to switch on it. And with every switch has cases. So you have three cases. It could be a deposit, or it could be a withdrawal, or it could be a fee. It can't be anything else because the hierarchy is sealed. So the compiler knows that there can't be a fourth kind of implementing class. And so therefore, I don't need a default here, and the compiler is going to be happy. Notice that there are little arrows here, and they mean that this is not a traditional switch, but this thing yields a value for each branch. In this case, I just want to know by how much does the balance get updated, and it's either plus amount or minus amount, depending on what the nature of this thing is. So this kind of switch here gives a value. Also notice the deconstruction that's happening here. When my bank transaction, lowercase b, instance is an instance of deposit, well, a deposit has a value sticking in there, then that value is bound to this variable amount here that maybe artlessly I gave the same name as the component, but it doesn't have to be the same name. It could have said var a. And so it automatically deconstructs my my variable. So my object of this record. And so you have this nice syntax that is perfectly constructed to work well with these kinds of hierarchies. And so there's actually a book out with Manning's previews by this guy, Chris Keel from Amazon, who's trying to kind of give a systematic approach to how to find good situations in typical business domains for this kind of modeling. mean, you wouldn't want to go and model your entire business out of records, but they typically are bits and pieces of business applications where this is perfectly nice. And so the advantage from a programming perspective should be kind of obvious, that you don't have the heavyweight OOP with needless encapsulation. You don't have to worry about inheritance hierarchies and overriding methods. You simply kind of code the data that are there, and you code the business logic and saying, if there are multiple cases, we need to handle the multiple cases. So that is what pattern matching is in a nutshell. These constructs work in the Java that you have today. So this pattern matching switch that you see here has been available for some amount of time. Maybe some of you have actually used it. But the idea is that people should be thinking about the parts of their business logic where this is a useful modeling strategy, and they should then consider embracing this kind of pattern matching style. So looking at this pattern matching switch again one more time, notice that this switch, unlike the classic switch, is an expression. It yields a value. It yields a value in each of the three branches. Whichever branch is actually taken, there's a value. That becomes the value of the switch, and that is then what gets used with a plus equal in this situation. Whereas the traditional switch, you had a statement or multiple statements in each case. We already talked about the deconstruction, that in each step, that this object that gets passed in gets taken apart into its constituent components. Here we have a wildcard that says you don't really care about this component in this particular instance. These cases are exhaustive, meaning all possibilities of the sealed hierarchy are there. If later on you were to change your hierarchy and add a fourth kind of transaction to it, this switch would no longer compile, and it shouldn't compile anymore, because what would it do with that fourth thing? Instead, you would have to revisit it, and that's just the way it should be. Of course, you could have done this before. You could have written a sequence of instanceof tests, but that would have been pretty painful. You could have added a method to the interface, but that's also kind of painful if every time that you have a new idea for some kind of business logic, you have to add a method into the hierarchy. Whereas here you could just do it in an ad hoc way. There's more to what you can do with the syntax. There's what's called a guard. So I can say, in the case of withdrawal, I can then put in a condition. There's this guard clause with a when, and I can say, when the amount exceeds the balance, then I'm going to throw an exception. So that's a feature of the syntax to put these guards in front of some of these cases. With guards, of course, then it becomes hard for the compiler to tell whether the logic is exhaustive, and so then you always have to put an unguarded case below it so that the compiler can track that. The compiler cannot evaluate this logic. Another thing that you can do is you can do nesting, and that's a very powerful feature if you have nested records. So I'm giving you here an example of a nested record where the withdrawal record has itself another component that is a record that's here called account. And then let's say that the account has an ID. Then I can say, if I have a withdrawal where the first one is an amount, it's a double, and the second one is an account which inside it has an ID, then I can fish out the ID in this particular way. So you might have seen that in JavaScript. You can do similar things, but here you can now do this in Java. This exists in Java today. So if you model the world with records, some of them are nested. You have a question back there?
Sorry, yeah, with the when syntax there, I haven't seen that before. Could you use a private method there? So
yes, and you can put any code at all behind the when. Yeah, except maybe calling system.exit. So the syntax is simply when, and then there's a Boolean expression of any type, and it gets evaluated. What this, of course, tells you is that these kinds of switches, they are executed top to bottom. Each condition is evaluated one after the other. everyone, so I hope that this power of having these nested things sinks in. You can you can describe what the nesting is, and you can fish out what other variables you want, or put underscores if you don't want them. Now, there's a buzzword to describe these things. So in functional programming, one calls these things algebraic data types. And it's a big word for something that's actually no harder than what you've seen on the previous slides. We use records that have components, and you have a sealed hierarchy, and that's what gives you the exhaustiveness. But the theory people, they say that the record is a product of the component types. So they would say that the phi has two components, the double value and the string description, and it's a product because you can combine them both. That's what they would say. They would say that the sealed interface is the sum of the implementing types, so that a bank transaction is kind of like the sum of deposit and withdrawal and fee. And so you can make some amount of sense out of this. And it's and so because plus and times have to do with algebra, they call them algebraic data types. I think that's a really lame way of doing it, but be that as it may, it is something that has a theoretical foundation. And it really, for us, just means we have records that describe data. We have sealed hierarchies that describe finite variations of what those data can be. And if you have that structure, then pattern matching is perfectly suited to that, because you can dig into each of the cases with a switch in each of the sum cases. And then once you have a record, you can get each of the components with deconstruction. That's all it says. So as a hypothesis, seen something like this, in a functional language like Scala, one would have defined optional a little differently than it is defined in Scala today. One would have said, well, really, optional should be the sealed interface. And there's two kinds of an optional. There's an optional that has stuff inside, and there's an empty optional. And you would have written it by saying that you have two records that implement this interface. And then when you have an optional, then you can just use a switch on looking at it. You say either it's a case of something, and then here, this T here, oops, syntax error, it should have been var T here. That's the Java syntax, would fish out the thing that is wrapped in the optional, and otherwise you have an empty and you do something about the emptiness. That might be a little bit more pleasant than what you do now, where you call, what is it, get or default? I can't even. See, that's the thing. I can't even remember, because it's some method that I have to look up every time that I use an optional, whereas this thing is a language construct. And once you master the language construct, you never forget it. So that's these algebraic data types. It's a bit more of the things that you can do. Type patterns, where here I have a case that I have a phi, and I want to not extract its component. I want to, for whatever reason, have the entire object. Then the syntax is like this. I say this is the type. This is the name of the selector that's now being cast to this type. It's called a type pattern. And so I could have written this with an instance of operation. And in fact, because there's something built into the Java pattern matching syntax that says that instance of and cases really are very much related. And so the syntax has been unified so that you now actually can say if a variable is instance of, and then you see the same construct back here where you have the name and of the type and then the name of the variable. And that means exactly what you think it means. It means if this thing was an instance of phi, then bind it to this variable f. Notice that this piece of syntax here is the same as this piece of syntax behind the case, and that is by design to unify instance of and switch. So it also works with deconstruction pattern. I could say if selector is an instance of with phi of, and here I say, okay, I don't care about the amount, I want to know the reason. And so this is the classic instance of thing that you can now use to do a type test and a deconstruction all at once. When you need to do this, then it can be kind of handy. What happens if selector wasn't an instance of phi? Then, of course, nothing would happen, just like with instance of today. So there will be more to come. At one point, it will be so that you can do deconstruction on other types, such as map.entry, that type that gives you both the key and the value of a map when you do an entry set. And you'll be able to declare variables in this way. That's very much like what you can do today in JavaScript, where you can say, I want to declare two variables, key and val, that are the deconstructions from this element. So that's on the drawing board, doesn't exist yet. Everything that I've shown you so far does exist in Java 25, but this will come at some point in the future. But the idea is that these patterns are going to be usable in the modern switch, in the modern instance of, and at one point in these modern variable declarations. So let's make a little thought experiment and say, can we do this with JSON? Why might we want to do this? Of course, you can, today, if you do something with JSON, you probably use Jackson or some such thing. But what if you just need to write a little utility and you don't want to put in like the full power of Jackson? And then wouldn't it be nice if the standard Java API had JSON in it? Like it has XML, why not JSON? That's actually why it doesn't have JSON, because XML was not a good experience. And so there's been a bit of a fear to put in JSON. But wouldn't JSON be like a perfect example for sealed interfaces and records? Because what every JSON, there's only so many JSONs, right? There's three primitives, 3 or 4, 4 strings, numbers, nulls, and booleans, and then there's 2 other things. There's objects and arrays, and that's absolutely it. It doesn't get more sealed than that. Each of them is just pure data. Right, a string has a string inside, a number has a number inside. An array has an array inside, and an object has a map inside, I guess. So you could model it like that. Oh, and actually, an interesting minor thing here. I've done everything as records except those that are finite, namely JSON Boolean. I use as an enum. You can have an enum implement an interface. I don't know if you know that. And so actually, my algebraic construction is here that every infinite type, I use a record, and every finite type, I use an enum. Can be done. And I can pattern match on this thing. If I do this, then I could write pattern matching in the following way. I can say, if this JSON thingy that was handed down the wire, if it is a string, I extract the value. If it's an object, I extract the elements and look at whether there was one with the ID and so on. So I can use this switch here and analyze my JSON object just using what's in the language. I don't have to learn much of an API. Nice. Unfortunately, it's not as nice as it could be because there's no nesting of records here, so I don't really benefit from nested patterns. And that if you do this in JavaScript, this nesting works actually pretty nicely. You can say, I have this thing that inside it has another thing that has an ID, and I can match them. And the syntax here does not really support that, at least not today. So there was a proposal last year to make JSON a JSON library for standard Java. And so I have a link in here for it. And if you look at it, you'll see that it actually does not use records. It uses very classical OO style programming. And so that's kind of why. So there are limits to what you can do with it as it exists today. So again, when do we want to use this? If you have a hierarchy of data classes. For now, that means records. But there is more general deconstruction in the works. So there is a proposal. Oops, I should have maybe linked to that. There's a proposal that came out a few weeks ago about something called carrier classes that are going to be kind of like records, but they can have their own state. They can have inheritance, but they need to still have a set of components just like records have. It's very raw, so I don't want to get into the details because it'll surely change. But they will crucially have a way of getting at the components, of having a deconstruction mechanism. So things like optional will, at some point, you'll be able to use them inside a modern switch. The things with the map.entry will surely work. And also, when right now you say, well, I would like to use a record, but I need to cache some data or something, you will like these carrier classes that will come up. So when you have a hierarchy like that, it's important that it should be sealed, because The ceiling means that inside your switches, you don't have to put defaults. And so you would generally then use switch to analyze instances of these data classes. There's a pleasant syntax that you've seen for guards and nested patterns. This is all good. So the question that I had when I first saw this many years ago is, why'd they call it switch? In Scala and Python, it's called match, like in pattern matching. In Kotlin, it's called when. In C# and Java, it's called switch. And, why not? I mean, these are constructs that we've had for many years. So I've looked up in Kernighan and Ritchie's C book from my college days, their first example of a switch statement. So in the C programming language, basically made it easier. I told you I was an assembly programmer at the time, and then it just became more productive to write the code in C because the compilers were getting good enough, and I enjoyed being able to write branches and loops with those constructs. And so I wondered, why the heck did they put in a switch? And there's only one reason why switch was put in, and that is to program what's called a jump table. So let's see if I can zoom in on this here a little bit. So if we look at what actually happens with the switch, that there is a table of memory addresses that is keyed either by index or by using a binary search on the cases. And then there's an actual go-to that says, take this memory address and jump right there with what's called an indirect jump. You could not program this in C. And that is the only reason why there is a switch. This is what's called the computed go-to is fast because you don't have to have to go through a bunch of if-elses. You simply make a table lookup and you immediately jump to the right code. So this computed go-to is what you want. You can't implement it otherwise. Does it have anything to do with pattern matching? Well, I guess there are cases. But it's completely different from pattern matching in that pattern matching is inherently sequential. And you've seen that with these guards. It's important to do these in the right order. Whereas a switch is you make one lookup and then you make an immediate jump. There is no do this, then this, then this, then this. So in that case, it's the exact opposite. Also, we've seen that the switch is a statement, whereas the pattern matching is an expression where each branch yields a value. So that's also different. Nevertheless, the decision was taken to say that in Java, we're going to be using the switch syntax for pattern matching because the case kind of thing is something that programmers are used to. So as a reminder, in Java 1, we had switches on int, short, byte, and char. Why int, short, byte, and char? Because those were the situations that worked in C. No one was eager to having jump tables with double or float entries. Boolean didn't seem to be worth the trouble. And what other type did I forget? Long. And a jump table with long seemed ridiculous. So that was not done. Java 5 gave us strings. Now, can you have a jump table on strings? You jump on the hash codes. You first compute the hash code of the string, and you use that as the index into the jump table. Enums, seems reasonable enough. There's a finite number of them. You jump on the index. And the wrapper types that were introduced in Java 5 for generics. But only the wrapper types for those for the regular C-style primitives. Java 14 gave us the switch expressions as a warm-up for pattern matching. Java 16 gave us instanceof patterns. Java 21 type and record patterns. Java 22 gave us the wildcards. Java 25 gave us, and I'll come to that. One of the reasons I'm sure you all came to this presentation is this: you said, I want to switch on a float. And so now this is in preview, and we'll get into that in a minute. So there's more work ahead. Like I said, deconstruction patterns, carrier classes that will enhance switch further. Did you know, does everyone in this room know that there's actually now 4 kinds of switch? So if we look at this diagram here, there is the switch that I've just shown you, where you switch and each of the branches yields a value. And so the whole thing is an expression. And there is on the other side, there is the classic switch, this one here, where you have fall through, because you have to put a break after each of the cases so that it does not fall through into the next thing. That's clearly, that comes from the jump table behavior, right? Remember the jump table, we have a case, we jump into the code, and then we chug along, and then that break is essential so that we get out of the switch. And so that still exists. To make it easier for you, ladies and gentlemen, to learn all of this, they said, let's give you 2 more. Namely, to fill in the missing combinations, to have a switch that is a statement without fall through. And you indicate that with the little arrows instead of the colons. Arrow means no fall through. And you could have an expression one with fall through. I'm not going to go into the nasty details of the expression one with fall through. You'll notice tantalizing yield things here. And so I'm already going to tell you just to stay away from it. It wouldn't be Java if we didn't have to worry about null. Switch has always been null hostile. So in null selector, the selector is the thing that goes inside the parentheses in the switch. In null selector throws a null pointer exception. Of course, that's only since Java 5. In Java 1, you could only use primitives, but in Java 5, they added strings, enums, and wrapper types. Well, they could be null, and in that case, naturally, the switch would throw a null pointer exception. What else should it do? Now, nowadays, switch can have so many more things, can really have any type in there. And so now it was decided that this sometimes you might actually want to have a case null where you want to do something else in a null pointer exception, and you can put in a case null. So that's nice. So it means that you can toss in case null, and that turns off the null hostility of switch. So the compiler looks at seeing, as soon as it says case null, then says no more null hostility. Instead, I will just explicitly handle it like this. Fun fact, default does not cover null, because historically it didn't, so they didn't want to change the semantics. Exhaustiveness does not check for null. So the switch that you've seen on the very first slide, where we had the 3 kinds of transactions, didn't say anything about null. And in that case, it'll, of course, throw a null pointer exception. It will not give you an exhaustiveness error. Weirdly, or maybe not so weirdly, null can happen in nested patterns. So have a close look at this little puzzler here, where I have a box type, a generic box that has a content of type T. As one is wont to do here, I'm going to have a box of strings. And I'm going to make that by having a new box in which inside I don't put in a second box, as I maybe should, but I'm going to put in a null. And now I'm going to have this switch here where I say, okay, my case is, I have nested patterns. I say, I have a box and a box of strings. Well, this double box thing here, of course, is cheating because there's a null in here. So what's it going to do? It can't work, right? Because it cannot go into the outer box, fetch the inner box. There's already a null pointer error then. And so, of course, it throws a match error. Why doesn't it throw a null pointer error or exception? The philosophy here is that whenever you do this kind of unwrapping, any number of things could happen. The methods that you use in the record could theoretically also throw an exception. If any exception at all happens in the unwrapping process, that's deemed a match error, and that's the failure. That's it. So anyway, so the nullness that you need to keep in mind is that traditionally switches are null hostile, and if you don't have a case null, that they stay like that. If you do have a case null, then that'll happen. But if you have a nested nulls, then you can actually now get a new error type. So that's nullness. So quick question here. Let's look at this switch here. Does it compile? We have an enum color. We have a method go that returns. This is actually what kind of switch? It is a switch with fall through, but it doesn't matter because we have a return here. Right? Notice there's 4 kinds of switch now. So this is an old-fashioned switch. Will it compile?
Yes.
Yeah, I know it should, but it'll say missing return statement. Why? Because the logic here is the following. It'll say, well, what would actually happen if at some point we say we add purple? And if this thing was in a separate compilation unit, not the same as here, then what should happen to the switch? Well, the switch would just do nothing on the purple. It would just ignore it, right? Because it's not there. But then there's a missing return here. And because this might happen, ever since Java 5, this particular construct said it's not actually complete. Has nothing to do with modern switch, has been there forever. So now let's make a teensy tiny change. Namely, I'm going to change those colons to arrows and move the return out. Will it compile? There's no default. Will it now complain there's no default? It will compile, because now they made the opposite decision. They said, we'll just throw a runtime exception if someone else added purple. And so there has been a history where 20 years ago, a decision was made one way. Now one makes a slight variation. Remember, there's 4 forms of them. And now the decision is a little bit different because this fits in better with pattern matching. And so if you look at the Java language specification, which I know you won't, then you'll find that there is a careful legalistic reasoning that sounds just like what you sometimes find in real courts that says why both of these behaviors are right. Here I have another situation here where I'm putting in a null, and does it compile? And okay, so see, I was actually, yes, no, I am right and wrong. So now I'm taking this thing back with the colons, and I'm putting in a case null. And by putting in case null in a classic switch, it turns it into an enhanced switch, and the rules subtly change. I don't want you to memorize any of these rules, but I want you to be alerted to the fact that because one has taken an ancient construct that has been enhanced in one way, and now one enhances it in a different way, that you have subtly conflicting rules. And so I'll try to teach you how to stay away from being tripped up by these rules. So in general, if you use the kind of algebraic switches that you've seen, where you have sealed hierarchies of records, then you don't normally, if you just stick to that and to the intuition that you have for that, where your basic intuition is case means, it's a case, then you're fine. Generally, using type patterns with instanceof are perfectly fine. You're used to instanceof. Now you have one extra feature where you have the binding. It gets weirder when your selector type is object. So here I'm having a switch on something that's typed as an object, because then you get a possibility of having the old and the new rules conflicting with each other. The good news is you will never have that in practice, right? Because it doesn't normally happen that you have a raw object in some business logic and then you want to make a decision on it. It's just you might sometimes find yourself, at a meetup where someone gives a puzzler talk, and then you see this. And then the rules do get kind of messy. For example, to show that, can I have a case of this is an object, right? Can I say if it's an empty string? No, because somewhere the rules say that you can only use a constant selector of type string when the selector type is itself a string. Can I have an enum? Yes, because some other rule says enums are totally fine And the reason enums are fine is that they are kind of useful. You've seen that JSON example. It does happen in practice that you have sealed hierarchies of records and maybe an enum or two for finite cases. So that's why enums are allowed. But so you do have inconsistencies in here. So here I have another situation here. I have a selector of type integer. I was able to do that since Java 5. Now I'm having a guard here. And so then later on I have a case 0. Well, the case 0 can never happen, but of course, and that's not so surprising. Java cannot really know that. It can't really understand the logic in here. Now here I have a default. And the default will, of course, also swallow the 0, and the compiler will not complain. Why? Because in Java 1, you were allowed to put the default all the way on top, or in the second, or the third. It doesn't really matter because it's a jump table, remember? And you might have wanted to do that because you might have to fall out without a break from the default into the next clause. Hopefully, no one codes like that. The case null, on the other hand, cannot be below the default because the default, logically should be less, even though the default never applies to case null. So the point that I want to make is that there is a number of subtle and messy rules. And so when you see a switch where the selector is an integer, then it's probably more of a puzzler territory than what you really have. I could come up with 10 puzzles on fall through. Those are easily avoided by never using fall through. Nowadays, fall through is no longer necessary or useful. You have 2 forms of switch without fall through. If for whatever reason you want to have a switch statement, if it doesn't fit the expression pattern, use the one with the arrows. But most of the time you won't even need it. But fall through behaves so confusingly with modern switches that I don't know where to put it. So here's the thing that I've promised you on on floats. So you can now if I can move this, you can now have this phenomenon where you can have an instance of or a case where you say, if my integer is a case of byte. What does it mean to be a case of byte? That means it's between minus 128 and 127, the range of bytes. So then if that test is true, then B here becomes the same as N, but typed as a byte, so you can use it as a byte without having to cast it. You can do that with floats. Why would an integer not always be a float? Because there's some integers because integers and floats are both 32 bits, there's some that cannot be accurately represented as floats, and then the test would fail. So that's a brand new feature, preview in 25 and 26 that will be added, where you can do these kind of type tests. They have nothing to do really with pattern matching, right? Pattern matching has to do with types and objects and things, but they've tossed them in because maybe it's unsatisfactory that so far you couldn't use these other types. So they've now added that in. It's easy enough. Yeah.
We have a question actually.
Okay.
It's really good.
Okay.
So,
yeah, go for it.
Orbly, and I hope I pronounced your name right. How come Java did not go away from the switch and made a new construct, for example, matching, and that way get rid of some of the legacy and fresh start per se?
Yes, and so this was, of course, discussed at the time, and the stated reason was that programmers have experience with switch. And so one wanted to leverage that experience to make it easier for them to embrace these new constructs.
All right, thanks. Did that answer your question?
I hope the answer is no. So let me and actually have a bit of slide material on exactly that point.
Cool. Nice.
All right. So yes, but that really is, of course, a good question. So one puzzler So Brian Gutz says, it's puzzlers considered harmful. People learn nothing from puzzlers. And so I've taken most of them out, but I did want to present this one here. So this comes from Remy Fox. One of his poor students got tripped up by this. Remy is a professor who likes to have his students use the latest and greatest Java features. So he teaches them records before teaching them classes because records are simpler. Actually makes a lot of sense. That way you learn about methods and without having to worry about things like encapsulation. And so I've simplified this a little bit. The context was something with spaceships, and so I've taken out of the basics. So here we have a list of shapes. There's 3 kinds of shapes: rectangles, squares, and circles. And so we want to turn all of the rectangles into squares, as one does. And so here we're mapping this list of shapes turned into a stream, and say, now if it's a rectangle, where then I want to turn it into a square, and where the width is the x. I don't care about the y. And otherwise, I'm going to leave it alone. And then I'm going to turn it all back to a list because it was a list before. So does it work? Will it compile? Will it run without exceptions? And will it turn all rectangles into squares? So let's ponder this here a little bit. Will it compile? Well, this we have a default here. So we didn't list like all of the types here, but the default will surely take care of it. Will it run without exceptions? I mean, where would it have exceptions, right? Will it turn all rectangles in? Aha! And so now here in the front row, see, it always pays to be in the front row. Someone noticed that here it said double and double, but here it said int. So why does it compile? Well, it compiles because this is this new feature that tests that we had no interest in whatsoever because it has nothing to do with pattern matching. But this feature tests whether the double can actually be stuck into an integer. And so this feature now has bitten us, even though we had no interest in it. And it makes this code do the wrong thing. Namely, if the rectangle or the spaceship, in the case of the poor student, had coordinates that were integers, then the case gripped, and otherwise the default applied. So that is the danger when you have too many things piled on into the same programming construct. So, and so a practical tip, you can avoid that by never using int here. Always use var. Then you don't ever fall into this particular pitfall. But why was the pitfall there in the first place? So now pattern matching was there for a very good reason. It frees you from having to plan the perfect inheritance hierarchy. With object-oriented programming, if you want to have variation in behavior, you get that by overriding methods. You have a method in the interface, you implement it in different ways in each class. You have a new kind of behavior, you have to go into each class and add another method. Pretty brittle to do. So with pattern matching, you can just do it ad hoc. And pattern matching is kind of like switch in that it has different cases. And so that was the logic that, yes?
I have a question here. Sorry.
Yeah.
Can you go to the last slide?
Yes, absolutely.
Yeah, you said that this compiles even though we are using int and
Yeah.
the record is with a double.
Yeah.
What about if you put, let's say, when running, you put 22.5, what happens now?
Okay, so let's go through this. I'm sorry if I went through this too fast. So let's see what actually happens if the rectangle here is a 0.5 by something. Then this pattern here, it's a pattern, right? The pattern says, is it a rectangle, number one? And number two is the x component an integer? Well, if it was 0.5, that's not an integer. So it'll simply skip this case and go into the default and not turn it into a square. But it's unintuitive in the context of pattern matching, where we probably never wanted this. And it's an easy mistake to make. So and so if in fact, so the point I'm trying to make is that there's a rational reason for saying we might want to test, is a double in fact an int? It's not a useless test, but it's probably dangerous to give it the exact same syntax as we have for pattern matching. They're just two different things. And the only reason that they now appear on the same dinner plate for us is that they both are somewhat switchy. That they both have something to do with cases. And that's actually not so wonderful. I think it's not so wonderful. I mean, I'm sure the people who designed this will not think so. But that's kind of what I want to talk about. The message that I want to cross, that pattern matching is really nice. It is a useful technique, and this having that kind of switch that we now have is generally nice. The pattern matching is fine. It's just so the idea was that going from the classic switch and instance off to pattern matching would be a natural on-ramp for people to learn these modern features. In fact, it says exactly that in the JEP that introduced the 4 forms of switch, which still to this day not everyone is all that familiar with, but that says that you want to have you want to use the commonality of features to guide the knowledge of the programmer. The greater the divergence between switch expressions, that's the new kind, and switch statements, the ancient kind, the more complex the language is to learn, and the more sharp edges there are for developers to cut themselves on. So in order not to have so many sharp edges, it was decided to unify the old and the new switch, which has led to a very large number of sharp edges. I could give you a puzzler on each one of them. And so that's a bit sad. And so I'm worried a little bit about that people then take they say that pattern matching somehow is maybe not the right thing. In fact, many people, including myself, have given these puzzler talks with great glee, where we show that these kinds of things happen. And some people then have taken the lesson from it, that pattern matching is maybe not the thing. This is too small for you to see, which is why I have this little image here. This is what I had at a conference a couple of years ago. What group projects are supposed to teach you. It says communication and responsibility and so on, and what group projects actually taught students. And the number one lesson was trust no one. And so the fear is that maybe with switches we are at this point, at that point. And so it's there's more. Yeah. So the message that I would like to say is that pattern matching really does work great when you have records, sealed hierarchies, and there are these dragons that are there because switch has been there forever. It has its own historical baggage. It's to this day being driven into other places, such as testing whether something is a float or an int or a byte, and so you have these conflicts. So the question came, why did they do that? Why didn't anyone warn of this? And well, all I can say is I did. Someone shut off this thing here. I did, in fact. Steve Colburn wrote impassioned articles about why this was a terrible idea, but somehow it's these things happen, and so we are now at the situation where I think in hindsight it is clear that the pattern matching switch isn't really a switch. It's a different animal. It probably should have been given a different name, but we are where we are. It still is a super useful feature, so you should go and use it. Just be aware that keep the pattern matching switch far away from everything else. If you never write other switches than the pattern matching switches, you'll be just fine. And the other things are, they are weird. It is just that right now, there is a flurry of blogs that teach you how to use this thing with the float. and the only thing to learn from it is to never use it. That instead to avoid it by not like in the SpongeBob thing, by never using int and float, but always to use var. Burn that into your brain. Probably your IDE will also warn you from things like that. But so we have the thing where we have a super useful feature that is marred by legacy syntax and legacy semantics. So that's kind of what I want to have. Questions?
No questions? You need to ask questions because we are way too early. You know, we cannot end that early, else maybe Kai has to tell some stories. Yeah, maybe, you know, there's one I was kind of curious about. I was wondering, so looking back, did anyone ever warn that using the switch keyword was a bad idea?
Yes.
Hmm.
But those warnings were loudly ignored. I mean, it was very obvious at the time that that this train wreck was going to happen, but somehow, and I guess what surprised me is that it keeps on happening. So when I saw the float thing, whatever. It is what it is. People can have different opinions on this. My message here is, just be aware of this little wrinkle and don't make that, not use the pattern matching switch, which really is very nice. But let me ask a question that I wish someone would ask is, should I now use records more often? Should I use them for everything? And I think not really. I think records are very good if you have something that's described by its state, and that description is invariant over time. And the internal implementation, it has nothing that you would ever want to optimize. When you say that a bank fee has an amount and a reason, that probably is going to be true for a good long time, and you don't really need to worry about it. That's fine. If you have a date, on the other hand, would you really say, I want to have a record that says day, month, year? I mean, we know from years of date libraries that probably would have been a bad decision, because you want a better internal representation, this. And so it really depends on what it is that your type is. A lot of times people say, I do want to have this thing, but I actually also want to have some kind of optimization, some cached internal state or something, and then records can't do it. So I think you don't want to reflexively tell your chatbot of choice to, in the general instructions, make everything a record. So that's why I like that book that I referred to it on the second slide or so by Chris Keel, because he tries to go through some actual examples from real business cases, and you can see him carefully extracting which things can be well modeled by records. So I think it's not a trivial question of what a record should be. I saw a very timid hand going up there. No.
By the way, Kai, actually, Boslur asked a question. He said, I would always love to hear stories. So maybe you have some to tell.
I have one question.
Yeah.
Oh.
I'm just curious, and this is the first time I've seen this feature, right? So when you're doing matching, because I'm someone who is very cautious around instance of, for example, I've never been fully comfortable using it because we have subclasses and so on, things like that. So in the scenario where we're matching on object types, can we potentially also be matching in an instance of way where we could also match a subclass? In other words, does that sort of complexity come into pattern matching here at the switch level?
I see. So that's a very fundamental question. And so the switches are good when you have a sealed hierarchy. So a sealed hierarchy means that you a priori say, I'm only going to have these types. If you have an open-ended kind of hierarchy, then I think the classic OO dogma does hold that you probably do not want to do the instance of switches, because that is brittle, and then you more likely will want to do something where you do add more methods. What is my phone doing? And so that's a decision you need to really make. Probably today you're not doing a lot of instance of.
No.
And I'd say that's generally the case in business logic. You're not going to go say, I have this weird hierarchy, I'm going to do instance of. But when it is nice to have variation of data with records and with some common super interface, and then using this kind of ad hoc decision is fine.
I can, by the way, say, Kai, that at my current customer, for example, where we are mapping stuff by hand, we do use instanceof quite a lot, actually, because, you get an enum and then you need to map it over to another enum, for example. This is quite common for those cases, but I really hope that most people use mapstruct or something like that. I would also love to use it, but it's a choice they made, so yeah.
Yeah, but I think in general, if you see excessive instanceof, it's a bit of a code smell, and you ask yourself why you did that.
And by the way, we have another question from Baslur. So he asked, how do recent developments in Java influence what and how Java should be taught in academic courses?
Well, that's what Remy said. He said, I'll start out with records, and I do not know why my phone. So I will start out with records. We'll use pattern matching right away, and then later we will introduce concepts like encapsulation, overriding, because they're much more complex. You want to get beginning students into interesting algorithmics and not so much into the deep mysteries of OO. And so with modern Java features, that's absolutely the right thing to do. So if I were to, in fact, I am rewriting core Java for the impatient in exactly that way, where it first says, here's records, here's how methods work. And then much later, I'll talk about how overriding works. Yeah.
Actually, sorry for my ignorance
No.
about my Java level. So we always talk about records. What about the normal class?
So a record is like a normal class.
Well, say, for example, I don't just ignore the word record. For example,
yeah.
in C#, I would say you can just define your own deconstructor in order to say return this like functional loading. So, for example, is it possible to do something similar, like I may have different deposit case statements with deposit decomposition patterns, for example.
Yeah. So the question was whether in Java today one can define one's own deconstructors, and the answer today is no. That is what's going to be at some point coming with these carrier classes that are being talked about today. So C# is ahead of there, or so is Scala, where you can define custom deconstructors. So in Java today, if you want deconstruction, you must use records. And so sooner or later, there will be a kind of classes that will allow for deconstruction without having this the strictness of records. With records right now, you can't have any state other than what's in the components. And so there will likely be something where you can have other state, and you will be able to manipulate that. And it's up to discussion whether, like right now, what you get with records is you automatically get hash code equals toString, which is a nice feature as well. So whether these what's called carrier classes will have that, I think they will, but not everyone agrees with that. Yeah, so this is definitely very much in flux and something to look in the future. So my advice, it would be, if you can use records today, go for it. But if something stops you from that, keep watching this space. There's more to come. Yeah.
How is the potential of refactoring of existing code in a data-oriented way, like here? So, what are kind of prerequisites? We need to have records. So.
Yeah. Let me just repeat the question. So there was what is the potential for refactoring an existing code base to isolate the records, that would make sense in this. And I'm not sure there is a huge amount of potential. I mean, if there's an obvious case where all you have is boring getters and setters, right, then you might as well make a record. And you see that sometimes like in data transfer objects, but they often don't have a lot of really interesting logic in there. Nevertheless, go ahead and refactor them. There's no reason not to. But the more subtle question is, can you organize your business logic so that you can capture interesting state? That is, I think, not so simple. And that's where I do, once again, give my shout out to Chris Keel's book, because it makes you think about those kinds of scenarios. So it turns out there's specific mechanics that I think are well expressed in this way, but it's not like a panacea for everything. That's why I don't like the term data-oriented programming, because like object-oriented programming had the idea of it would replace programming as we knew it, right? Everything would be object-oriented. And I don't think everything will be data-oriented. It's good for some things, but it's not a universal solution.
Because it struck me at first time, if I go and develop from scratch this way, it makes sense everything. But refactoring of the existing code, it really needs to fit really to that pattern that I need to have immutable classes and similar objects, similar logic, so I can feed them into the switch statement.
Yeah. So So the concern was that there might not be a lot of opportunity of doing refactoring, because if the existing code base, the classes are not immutable, or the logic path is not so that you can easily do this. And I think that's true. So I think this is more for design for new things, or for a bolder thing than just automatic refactoring. All right. Well, I think that gets us to the end of the hour. So thanks very much for sticking with it in this horrid weather. It was great to have a live audience for this. And so I hope it looked good on your end, Francois.
It totally did. And I actually have a good closing statement, or like a good closing joke for, the end. Marcos Garcia said, "One of the best records feature is giving us the opportunity for throwing Lombok away."
Yes.
There is some merit to that. Yeah, thank you so much, Kai, for your great presentation. I really enjoyed it, and I hope you all did too. And yeah, please give another big round of applause for Kai.
Okay, so you're turning off the StreamYard then?
Yes.
All
right. Bye, everyone.
Okay, bye.
Bye.